Now for example 8. So we're going away from aircraft now. We have a boat, and we're told that a boat's propeller shaft transmits 50 horsepower at 100 RPM. Determine the minimum diameter of a solid circular section phosphor bronze shaft when the maximum permissible shear stress in the shaft is limited to 40 megapascals. What will be the resulting angle of twist of this shaft due to this torque over a length of 1 meters, given that the rigidity modulus is 40 gigapascals. Again, we're told that 1 horsepower equates to 745.7 watts. And this is the answer we should get. Okay, so first thing I'm going to do is take that 50 horsepower. I'm going to convert it to watts. So 50 multiplied by the 745.7 down here, that gives me 37,285 watts. So my power is 37,285 watts. These are the standard formulae that we use, and we have some information. So we have the 100 RPM, so I have N for 100, and I have shear stress, so tau here is 40 megapascals, and G, should have highlighted that, that's 40 gigapascals, so we have 40 here and here. Okay, so we'll begin with the omega. So we were told it was 100 RPM, so 100 RPM works out to be 10.5 radians. Power is torque times omega. I can rearrange that to get torque as power over omega, so that is the 37285 watts divided by my 10.5 radians per second, and that gives me a torque value of 3,551 Newton meters. I then take this equation here and bring it down. So instead of the T, I'm going to put in 3,551. J, well, we don't know what the diameter is, so we're just, and it's a solid shaft. Yep, it's a solid shaft, so it's pi d to the power 4 all over 32. And these just are unchanged. Alright, what I will do is get rid of the fractions here. So this side of the equation, I'll multiply above and below the line by 32. And I'll multiply above and below this line by 2. And now I'm going to cross multiply, so I'm going to bring the d to the 4 up over here and bring this expression down to this part. Okay. So d to the power 4 divided by d is d cubed. So if I want to get d, then I get the cubed root of all of this. So the cubed root of that expression works out to be 76.8 millimeters, which is what we had hoped we would get. Alright, second part then, we're going to look at this part of the equation here. So I have 40 by 10 to the power 6 d, so my d value is now 76.8, which is 0.0768 meters. G is 40 giga, so that's 40 by 10 to the power 9. The length of the shaft was 1 meter, so that's 1 meter here. And I'm just going to cross multiply to get theta. So theta is equal to all of these. When I put those into the calculator, that works out to be 0.026. Now, theta is measured in radians, so this is 0.026 radians. Now, recall that 360 degrees is equal to 2 pi radians, so that means 1 radian is 360 divided by 2 pi degrees. And then if I want to get 0.026 radians, I'll multiply both sides by 0.026. So 0.026 radians is 0.026 times 360 all over 2 pi. And when I do that, I get 1.49 degrees. which is what we'd hoped we get.